L04, moment of inertia for a rod. So let's consider a rod about its end. So it's going to go around this axis here. And this is our origin. So we're measuring out to some here dr. So here is r. And this here is a dr. The total mass is m. And the total length here, big L. So we can think of this here as a little dm, a piece of mass, and we'll have our formula integral r squared dm. Now it's convenient in these problems to define a density. Here we have a linear density. I like to use lambda for linear density, and that's the total mass m over the total length L. So the piece of mass here, the infinitesimal delta m, or dm, is going to be equal to lambda times dr. Just like here, the total mass is equal to lambda times the total length. This is the proportion that would be relevant for the dm, this little piece in here. So now we have the integral r squared for dm. We're going to replace that with lambda dr. The lambda is a constant, so that can come out. And then here we have r squared dr, and we need to integrate to go from here r equals 0 is this axis out to r equals L. So you want to go from 0 to L. So this integral is r cubed over 3 from 0 to L, and that'll be lambda times L cubed over 3. Now, the last step is to replace for lambda the m over L. So m over L times L cubed over 3, and L goes out, and we have m L squared over 3. So we have, for the moment of inertia, and I'll just emphasize this by saying end, about the end, is 1/3 m L squared. Now, what about the center of mass? In other words, what about putting the axis in the center so that there's L over 2 on each side, and we're going to spin around this way? What's the moment of inertia for the center of mass? Well, we have the parallel axis there that states that the moment of inertia is equal to, it's in general, the moment of inertia of the center of mass plus the mass times the distance that the axis is away from the center of mass. Here, the distance is L over 2. Now, we do know the end, so let's go ahead and let's go ahead and write this equation out again and apply it to the end. So if you apply that to the end, then we have I center of mass plus m. The d now is L over 2. So we have L over 2 squared, and then this can be put in here. We can solve for the I center of mass. So 1/3 ml squared equals the moment of inertia about the center of mass plus, and what do we have here? Well, we have 1/2 squared, so that's 1/4 ml squared. So our answer, I center of mass, is equal to 1/3 ml squared minus, taking this on the other side of the equation, minus 1/4 ml squared. And we're basically taking 1/3 minus 1/4 since the ml squared factors out. Common denominator is 12. 3 into 12 is 4, so that's a 4 over 12. 4 into 12 is 3, so let's just check. 4 over 12, 1/3. 3 over 12, 1/4, minus sign in between. So this is going to be 4 minus 3 is 1, 12. So therefore the center of mass, moment of inertia, is 1/12 times ml squared. A baton is approximately a rod. And here, this person has her hand in the middle. So if you twirl the baton about its center, your moment of inertia about that center is 1/12 ml squared.